Alright, and this is section 2 of moving from prototype to production and trying to get some time savings. The first section we went over fixture design. Now we'll go over a couple of strategies I use whenever I'm programming. We'll go back to that initial part. And remember, this all the toolpath here is very concise. It comes down, does exactly what it's supposed to do. There's no wasted motion, but still it's too slow for production. Even though it's got some really nice linking moves in here, right? It's still not. It still could be considerably faster if we consider a couple of alternatives. One is whenever I'm going into a production job, I think, is there a possibility for some custom tooling? Because that can save you a lot of time. Some of the easiest ones to come by are combination drill countersinks. Even though they're custom, there's shops that specialize in that kind of drill and countersink and little end mills with chamfers on them at specific diameters and angles, and that can save you a lot of time. Another thing I do to save as much time as possible is I consider all my rapid motions, and then when you hear the word rapid, you think, okay, that's as fast as the machine can go. Well, yes, but it has to get there somehow, right? Here's a yellow high feed motion. It's linking from contour to contour. And if you zoom up on here, that tool, as he's coming across, he starts to decelerate, right? And then he comes to a complete stop at that 90 degree. And then he starts to re-accelerate, okay? And then he goes right down into cutting. So at some point, he comes into a complete stop. And how many times does he do that in this part? All these 90-degree motions, bump, stop, stop, stop. And those things can start taking a toll on your time. So what I do to avoid this is I create some of my own linking motions. I draw in my toolpath by hand and make sure that there's a radius that leads into every cut and that blends every cut. And then because these are lying on the same Z-plane, the linking motion kind of just, whoop, that's automatically added in there. I only drew little cells of toolpath. And if you look at the time difference on this, it might not seem like much, but that's just with some contours. And this is the exact same tool and feeds and speeds and everything. And you saved about 10 seconds, and you probably saved more than that because the software might not calculate that dead stop, exactly for every machine. So I use that a lot, especially on this kind of high run production stuff. Even on doing contours on the sides, mainly on roughing motions. In this one, if you did a contour, it would cut all the way down, right, and then it would wrap it up, come to a dead stop, wrap it all the way back, come down to a dead stop, and so on and so forth, and keep cutting in one direction. But there's no need for it to cut in one direction here. You can cut conventional, and I mean when you're doing a slot, it's not really conventional. It's not really climb cutting anyway, right? So boop, 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 boop. He gets in there, does what he's supposed to do. He rapids up. So instead of 1, 2, 3, 4 dead stops, I get 2. I can deal with 2. And that saves a considerable amount of time, especially when you're doing 1,000 parts. Every 10-second counts, and especially when you're doing roughing like this, your machine might have some difficulty calculating those radiuses, and it might slow down a little bit depending on what kind of machine you have, and if you have high-speed machining enabled. But whenever I post out the program for this specific application, I make sure this operation, I make sure that I enable with this G-code operation here, G187. And what that allows me to do is, see if I can get it to pull up, I get a P command at the end of this G187. And that P command allows me to set the tolerance of how the machine will calculate that toolpath. So I can either do it roughly, or I can do it a finish. So every program is going to be different, and this p-value stands for the quality that the toolpath will be rendered or calculated on the machine, and therefore how fast it's going to run it. Right? If it's just a roughing toolpath, the machine should calculate it very quickly, and you should put this down to level 3 as a finish. So I'd actually want to, because this is a roughing, I'd change that to a P1. And now he's going to calculate that toolpath a lot faster. So, and I can save that and put that to the machine. So that's just some time-saving tricks that I use in programming that allow me to save all those seconds by the time I'm done programming. Hope you enjoyed this video. If you have any questions, let me know. Like I said, I like hard problems. Thanks.